Back. This is the second video of polynomials and stuff. So let's talk about what it means if you're looking for the degree of a monomial. So the degree of a monomial is defined as the exponent on its variable. Okay, so those are just words. We need to look at an example in order for you to know what I'm talking about. So here's a monomial, one term, this says that the degree of a monomial is defined as the exponent on its variable. And so in this case, the exponent on its variable is 5. So this monomial has a degree of 5. Okay, so if I gave you another monomial like this, maybe negative 3x, I'm just going to leave it like that. And I asked you what the degree of this monomial is. Well, you have to look at the variable and look at the exponent that's with it. And in this case, the exponent would be 1. So this would have a degree of 1. Great, right? Okay, so this is going to bring us into the next thing that we're learning, which is the degree of a polynomial. And so when you're looking at a polynomial, that's not a monomial. It's many terms, right? It could be, I don't know, 2 terms, 3 terms, 4 terms. So let's look at an example. Okay, so if you're being asked to find the degree of this polynomial, it's defined by the highest degree among all the terms. So I have to look at all these terms separately and see what the degree of each of them is. For instance, the degree of this term is 3 because the exponent is 3, and the degree of this term is 2, and the degree of this term is 1. And this is a constant term, so we're not even going to bring that into contention. But the highest one here is 3, so we would say that the degree of this polynomial is 3. So that's the last few things that we've been looking at is how to find the degree of a monomial, and then how to find the degree of a polynomial. Okay, so now let's look at the next thing, which is simplifying expressions. So, okay, so these are polynomials, and we're just simplifying. This is an expression because it doesn't have an equal sign. So, we just want to simplify it. Get rid of those parentheses. So you can see I've kind of segued into something completely different from what I was just talking about a minute ago. I want to get rid of those parentheses by distributing the 2. So my first step here is rewriting this entire situation with the 2 distributed. There we go. And then we're just going to combine like terms. So terms that are like terms in this case, let's see if I can change the color. Oops, wow, that didn't work out for me very good, did it? Oh, that's a fill color. Right, okay. This term here can be combined with this term. This term here can be combined with this term, and the x term, the last one, we don't have any other terms to combine that with, so we're going to leave that. So 5 plus 6 is 11, 11x squared. We have this negative 8x, and then we combine the constant terms, which if you combine negative 7 with a positive 2, you'll get negative 5. And so here we go. We have a polynomial. It was simplified. Okay, so I'm going to give you one to try and give you a second to try it, and then you can pause and then come back and I will go over it with you. Here it is. So what you're going to do is simplify this expression. Come back to me when you're ready. Okay, so here we are. What we want to do is get rid of the parentheses, so I'm distributing, really it's a negative 1. If you have nothing in front of your parentheses, then you can stick a 1 there. So after distributing, I should have 2x squared minus 7 minus 4x plus 3. Negative 1 times negative 3 is positive. And then I'm combining like terms. In this case, the only terms that are like terms are these two. So I am pretty much just rewriting this as 2x squared minus 4x minus 4, because that's what negative 7 and positive 3 are when you combine them. Okay, so I have 2 more examples for you. Here's the first one. Take a moment, do this, pause, come back to me when you're ready. Okay, so add the polynomials. You've got one that has 4 terms. We don't have a special name for the 4-term polynomial. We just call it polynomial. Then we have a trinomial. So I'm going to add these up, and I'm going to do this kind of on the way down. I'm noticing that this is the only cubed term. I'm noticing that this term and this term are squares, and I'm putting different shapes around these on purpose. This term and this term are the x's, and then we have this constant one right here. So I'm going to put the 3x cubed first. I don't have anything to combine that with. Negative 5x squared combined with a 9x squared would be 4x squared, because I'm combining negative 5 with positive 9. The 7x and the negative 7x, they cancel each other out, so I don't even have to write anything down for that. And plus 2 on the end, so my answer ends up being a trinomial, simplified, adding those polynomials. Okay, so I'm going to give you another example. Here it is. Okay, so go ahead and give this a minute. You can pause it, come back to me as soon as you're ready for me to go over it. Okay, so I want to get rid of those parentheses, right? I need to distribute right there. I have a positive 1 in front of this, so it's not hard for that one to be distributed. Here we go. Minus 4x squared plus 3x and minus 10. There's no cubed term, so 4x cubed comes down. I mean, there is a cubed term. It's the only one, so I'm going to keep that down. And there's only one x squared term. It's minus 4x squared, so that took care of that one. I'm combining 13x with 3x, so that's 16x. And then negative 4 is combined with negative 10 to give me minus 14. So this is the simplified version. It's an expression. I simplified it after all this great stuff, and this was my answer. So I will be assigning homework based on the last few videos, and if you have any questions, post them on Schoology, and shall see you soon.